Joelle Givens, and we're doing a STEAM count this summer. This week, we are studying rocket propulsion, and we've done all kind of backyard experience science to learn about what propulsion is and how you make it, how you make a rocket propel. So we've done, that's following Newton's third law of motion. And for every action, there's an equal and opposite reaction. So we started out with the simplest, a straw rocket, where they would use air as their propellant. And we learned things like thrust that it has, and aerodynamics, trajectory, things like that. Go further, but if they had it at a 90-degree angle when it took off, then it would go higher. So the altitude would be higher of their rocket. Okay, rather than the distance. Then we did an alcohol rocket, and this is the alcohol rocket. And actually what he did here is Mr. Deshawn is going to demonstrate for us, and he lights the alcohol, and it actually works as the propellant for the rocket, and it makes a flame just like it would with a rocket. The last thing that we talked about, and we're going to watch the launch of it, is SpaceX. And SpaceX used to use the Merlin engines, but now they are using Raptors. They're called Raptors. And SpaceX, on their last space orbit of Earth, where they took off from Texas and they landed in India, they splashed down in India, then they used the Raptor engines, and the liquid, it was liquid methane and oxygen. Of course, in any kind of propulsion, you have to have oxygen that enters it, mixes with the liquid propellant. Is it going to take the highest or the furthest? Right, okay. And then what degree is going to take it the furthest? Okay.
Students tested how different launch angles affect rockets' distance by aiming toward Mars and Jupiter targets. This activity explored physics concepts like force, trajectory, and motion to see how angle changes affect flight path. As you can see, Mr. Deshawn built a simple pulse-jet engine prototype using a glass jar and controlled fuel ignition to study thrust and propulsion. This activity followed the engineering design process, also known as EDP, which has taught students how real engineers design, test, and refine systems by experimenting with airflow, combustion, and energy transfer.
So when it ignites, it's going to flash and it's going to put itself out, but it's going to reignite, and it's going to get the interval from flashing and reignition going to get a closer interval, and it's going to sound just like a rocket.
So you got to have fuel and you got to have air.
Yep.
Okay.
Although at first it was difficult to get a reaction, he still used the EDP and kept improving his design to figure out some type of a result. Next, students learned how air resistance, lift, and thrust affect flight by studying aerodynamics and modern space rocket systems like SpaceX. This activity connected real-world aerospace engineering to how rockets and aircraft are designed for rocket exploration.
This is the beginning rocket. What gave you the propulsion with a straw rocket?
Air pressure?
Yes. The air pressure from dropping the pit stove with straw out, and it flies. And what degree did it go the furthest? 45. And what degree did it go the highest? 90 degrees. What did we do yesterday? What kind of propulsion did it have? Air. And what gave it? What kind of energy was that? When you reach over and stomp it, what kind of energy was that?
The air pushed it over.
When you do exercises, what kind of exercise is that called? What kind of energy energy do you use? Kinetic energy. And we got fire. We'll work on it. And what process did we use when we couldn't get it to work?
Good job.
EDP. And what is that?
Engineering design process.
Okay.
The first day of camp was very fun and very successful for each student to learn something new.
Go Hawks!